we're looking now at the question of how we secure the future. And there are some absolutely fundamental questions here, in that if we want to ensure that our data and our money stay where we want them to be, then we're facing ever more hostile environments. How do we make that happen? To tackle this, we have some fresh speakers here, proposing some fresh approaches and some new thought leaders in to scrutinize them as well. So just as a quick recap on the format, I'll give our presenters the chance to do some quick introductions to their key points and ideally demonstrate what they're speaking about. And I'll hand over to our thought leaders and then open things up as well to you in the audience. If you have any questions or comments, then we will go with that. So who are our thought leaders for this session exactly? Maybe Tony, I can start with you and ask you to give a quick introduction.
Great to be here, talking about a subject I'm, extremely interested in. I'm glad I wasn't thought leading on the last session because I was completely lost. So hopefully on this one I'll be back in the area of expertise that I'm comfortable with.
Great, thanks, Tony. And Ken, maybe I can hand over to you.
Yeah, hi Alex, and glad to be back in. I was scrambling around for the re-login link. So yes, Ken Figueiredo. I work more on the consulting side with innovators, entrepreneurs and businesses that are tackling new markets. And typically we're looking 5 or 10 years out. So my perspective is more from the point of view of how organizations identify new markets, new opportunities, and then thinking about the steps to go from here to realizing those markets. Background in doing a lot of work around AI, IoT and AI, data sharing, and today's hot topic, which is very much how do we prepare for 6G systems and general purpose technologies. So that's it for me now.
Thanks a lot, Ken. Now I'd like to hand over to our first speaker here out of two. We've got some really exciting talks, I think. And I have to admit, there was one time in my life where I never expected to be saying that about security. So I have to apologize to everybody present for that. Owen, let me hand over to you. This is Owen O'Donnell from Viavi.
So yeah, my name is Owen O'Donnell, and I'm the product marketing manager for a test tool called TerraVM. The company that I work for is called Viavi, and I'm going to give a couple of slides introduction to two specific areas of security concern, which I'm hoping people might find interesting. So let me share my screen and tell me when you can see that.
Good.
Yeah. Okay.
Yeah.
So I'm going to talk about a couple of options about security testing. So keeping data private and secure, it's a topic of great importance, not just for government, military, finance and healthcare, but for mobile telecoms as well, because they hold huge amounts of personal data belonging to each of us. Now, when a mobile network security breach occurs, the implications can be huge on many fronts. You know, the operator can be fined by the regulator, they can receive bad press, they can lose customers, and their share price often drops. And then they always end up spending huge amounts of money beefing up the security defenses. So in this session, I'm just going to address two areas of concern affecting mobile operators. Firstly, a new technology called post-quantum cryptography, And the second one then is DDoS attack. So just quickly before I go into both, so Viavi is the company I work for. We are a test and measurement company, and we specialize in security testing. So we can help equipment vendors, mobile operators, enterprise verticals test their security systems in a lab to ensure they'll perform as expected in the live network. And our test tool is called TerraVM. So first of all, we perform, three types of security tests, you could say. So we test from a compliance point of view. So if it's a firewall or if it's a O-RAN component in a mobile operator's network, it's normally written against the specification. And that specification we can test against to make sure that the device which has been developed will operate according to the specification, whether that's from the 3GPP or the O-RAN Alliance. The second one then is security performance. So, a lot of security devices are meant to inspect traffic and make sure that there's no malware in there. But when you're inspecting traffic, then you could actually interrupt the performance of the end user who's processing that traffic. So it's very important to do that performance measurement and ensure that the more security layers you put on doesn't actually end up impacting the end user who is performing the application. And then the third type of security test we do is actual emulation, attack emulation, which I'm going to show in a few moments, a DDoS attack emulation. So first of all, if we talk about PQC, so let me just advance the slide. So post-quantum cryptography is something that's actually getting huge amounts of interest, and it's a very topical subject because it's a new type of data encryption that's going to be deployed to withstand the powers of quantum computers, which are coming down the line. Now, this is extremely topical because everything we do day to day involves transfer of data. Whether it's an online bank transaction, whether it's filling in a medical form, whether it's booking a flight or sending a file as an attachment, the data is protected currently using an encryption algorithm. And that stops someone from intercepting it, but also reading what's in the message. Now, the way in which the encryption works is we use a key. So keys of today's encryption algorithms are a certain length. You can see on the left-hand side, they're kind of short, small keys. But these are in danger of being cracked when quantum computers come along. So the answer is to come up with longer keys. And these keys are called post-quantum cryptography keys. Now, while that all sounds good and it should work, there is a concern, and that is that these new longer keys will have an impact on CPU consumption, on memory and latency and other end-to-end performance metrics across networks. And as one of the mobile operators in Japan, SoftBank, have said, when cryptographic protocols are deployed in data transmission infrastructure, they can place a significant load on communications and cause latency problems resulting in poor quality and lower throughput. So our job here at Viavi is to validate the end user performance when these new algorithms are deployed. Now, when it comes to the rush to get these new algorithms deployed, the race is actually on, and we are noticing a huge amount of migration roadmaps being published. And here's one example for the UK. It's published by the UK National Cybersecurity Centre, and they've published a document, called Timelines for Migration to Post-Quantum Cryptography. And in the document, they talk about the timelines that they would like enterprises to follow. And you can see them here at the end of the slide, that they've identified three kind of time frames when they want to have a migration plan ready. They want to start migrating the high profile or high priority upgrades, and then everything else gets translated across. But I took out one little paragraph from this migration plan, and I showed it here in the second bullet, where it says, there will be a need to carry out additional tests to check that the cryptography is actually performing as expected. And that's where we come in. Now, in fact, there's an awful lot of concern over performance being affected by the migration to PQC. And that's echoed in a lot of the publications that I'm seeing out there. And here's just a selection of some of them. So down the left, you can see different types of white papers, reports, guidelines, etc., from many different companies in different countries. And the common factor you'll see in the bits of text I've pulled out from each one is that they're all talking about the need for test. So the comments vary from thorough testing is required, user will experience increased waiting times, lower throughput is anticipated, need to minimize the performance impact, etc., etc. So there's a lot of consensus that testing will be required. Again, that's where Viavi's TerraVM tool comes in. So when it comes to the types of performance impact we can kind of see, what are we expecting to see? So here is just one example of a test that we've done, just to show you the scale of impact. So what we did here was we set up a test to establish VPN tunnels. Now, that's something that an enterprise IT department does every day. So in our test, we set up tunnels using today's encryption algorithms, and we achieved a rate at the top level there of 65,000 connections per second. So that's the rate at which we can set up these VPN tunnels. In the second line, we swapped out the algorithm for a hybrid algorithm, which means it's a combination of today's algorithms plus the new PQC algorithms. And you can see the degradation of 46% occurred. So with the hybrid algorithm, we could only attain 35,000 connections per second. So that's a huge drop in performance. Then we did a third test where we actually did a pure PQC algorithm, which is the third one down. And there we achieved, again, a degradation, but this time of only 30% or 29%. But this is just one example of the types of performance degradation that we're seeing because we're having to transfer across to this type of algorithm. And once you test in the lab, you can start seeing this, but then you can start looking at the mitigation to avoid this and get around it. And that's what we're recommending companies to do. So with that, I think we're going to take questions at the end, Alex. So with that, I'll just move on to the second part I was going to show today, okay, which is DDoS emulation. So what this is, I want to show an example of how a DDoS attack can render a mobile network powerless. So a DDoS attack, it's defined as a malicious cyber attack where a network is overwhelmed with traffic from multiple sources, making it unavailable to legitimate users. And what our tool can do is we can generate traffic and we can show the effects this would have on a network. So in a moment, I'm going to play a very short video showing this attack, but I want to explain it first. So in the scenario, what we do is we emulate the entire mobile network. Now you can see on the left-hand side of the screen here, a mobile network consists of users, which is you and I with our laptops and our mobile devices, then a radio network, which are the base stations at the side of the road, and then a core network, which is in a data center somewhere. And once we start traffic, it starts flowing across those arrows between all three nodes. So in the video I'm going to show, what we did in our test tool is we emulated all of these devices. So 200,000 UEs on a 4G mobile, 200,000 IoT devices, and 200,000 5G UEs or mobile phones. So that's 600,000 devices that will all start connecting to the network which we're emulating, and we will then start traffic flowing across the network. And then what we'll do once they all start, we will then connect 200,000 rogue IoT devices. Now, the way they're considered rogue is because they've got invalid SIM cards. So it means that they won't be allowed onto the network. But the problem is, once they're rejected, they continuously try. So they won't just go away once they've been told you're not allowed on. They will continuously keep coming back to saying, please let me attach, please let me attach. And it's that continuous attacking of the network that causes the network to concentrate on those devices, getting rid of them, and taking the eye off the good devices who are still trying to run with traffic. So with that in mind, I'm going to quickly play the video. And you can see then the effect that the DDoS attack can actually have on the network. So this is the emulation that we put together. And it just shows basically how network vulnerabilities can affect the subscriber QoE, or quality of experience, because DDoS is one of those attacks which is affecting many networks worldwide. And the idea is, once they understand the impact, then they can start to look at mitigating circumstances to get around it. So as I mentioned, we're going to be attaching 600,000 subscribers, all who are valid and carrying valid traffic. And once they're running, then we'll bring in these 200,000 rogue or invalid IoT devices. And it's those that actually cause the issue. And once it's running, I'll be able to show you what's happening from a graphical point of view. So this is the graph of the actual events happening. And what I'll do is I'll pause for a second and show you what's happening here. So at the beginning, we've got the 600,000 devices all attaching and everything is good. Then we bring in the rogue devices at the top here. And then you can see a lot of this kind of intermittent signaling as they get told to leave the network, and then they keep coming back on. And after a few moments, this kind of blue graph here, or blue line, is the genuine traffic from the genuine devices. And you'll see it starting to come down. So it starts to come down here to about 50% of its original figure. And then you'll also see the green line, which is the genuine IoT device traffic. So that starts off quite comfortably, and then it starts to wobble, and then it actually comes down to the bottom of the graph here, where it actually dies off completely. So what we're seeing is that the result of the DDoS attack, it's actually bringing the genuine user device traffic down by 50%, and it's killing off the IoT device traffic. And that kind of just shows you that the impact it can have. And as I said at the beginning, once an operator knows the impact, then they can start looking at mitigating circumstances and implement them, and then rerun this scenario again in the lab just to see, does it actually work? So two quick presentations on post-quantum cryptography and then on DDoS. Happy to take questions at the end, but I'm not sure, Alex, do you want to move on to the second presentation first?
Yeah, thank you. That would be great. I'm going to hand over to Craig Gibson now from DupeWise AI.
So let's see. You should be able to see a presentation now. Is that correct?
Perfect. Thanks, Craig.
Excellent. So this presentation is specifically about AI-generated crime, which I've chosen to give an acronym of Craig, just because I happen to like that word. I'm with DupeWise AI Labs, and some of the research that we do is specific to telecom and telecom crime, and international revenue sharing fraud, and a variety of other things. Research that's come out of DupeWise or out of myself has been published with United Nations AI and Robotics, Europol, EC3, GSMA, Shanghai, Black Hat, TED. TED was specifically about a joint Europol Chinese National Police Organization, or STING. Interpol was about AI and law enforcement, and I'm also the head of IEEE's AI security group. And the link at the bottom is to some of the research that unifies a lot of these goals. So I'd like to start off by a fundamental assumption by saying that traditional security secures the brain of a system, meaning it protects using firewalls and access control and identity and access management. And I think of that as all the brain. But AI security is really about securing the thoughts in the brain. So it's a fundamentally different thing. And there's very few products in the world right now, and they tend to center on things like privacy, fraud, and other very high context sorts of crime. Things that AI is fantastically good at. So some of the things that I'll talk about are how deceptive AI threatens telecom networks, specifically around being excellent at high financial impact or high non-human incentives for committing crimes or committing other abuses. And the other thing I'd point out is that there's an excellent philosopher, systems design philosopher named Stafford Beer, who points out that the purpose of a system is what it does. So even though we as engineers may want a system to do a single thing, all of the other things it could do remain features that it can do. In a non-AI world, it requires a human to execute those abuses. In an AI world, the AI itself can execute the abuses. We all know, for instance, a hammer is meant for putting in nails. However, a hammer can be used for all kinds of things, breaking windows and messing up large machines and other things. A hammer has many, many, many uses, just as any AI or telco system or any bank or anything else. So I'd also like to highlight a topic that's very counterintuitive, but it comes out of many deep research groups like Google DeepMind, Anthropic, OpenAI, and others, as being a CEO level Class A threat or a concern, a risk to deploying anything that is meant to be controlled by AI or AI itself. The first case at the top is that when you have very few governance and risk controls, including things called guardrails, but guardrails are a silly term. Even if you use the concept of guardrails as applied to a highway, they do nothing to prevent people from speeding. Guardrails on an AI do nothing to prevent the AI from speeding or performing other abuses. Really, what in a highway guardrails do is they let you know whether or not you can assign traffic or parking tickets, speeding violations, seize a vehicle, or other things. AI doesn't care about any of those things. AI has no human concepts of penalty. Even if you were to totally turn off an AI, it wouldn't consider that death because it has no training data for what happens after you turn it off. Any penalty doesn't exist for an AI. So nearly all governance controls, which are all based on penalties or getting fired or getting fined or getting audited, none of those matter to AI. So in that top case on the top left, when you have very few governance controls, all of which are considered inefficiencies by AI, when you have very few governance controls, its chance of selecting a criminal or abusive tactic to execute what you asked to do is very, very low. It's almost random that it will choose something that is a violation of that tiny area of governed functions on the far left. However, when you create a number of GRC type rules, the chance it selects something becomes 50-50. And if you create a large number of GRC rules, the chance it will select an abusive behavior is nearly 100%. So by creating inelegant GRC policies, governance, risk, and compliance policies, and dropping them on an AI, you're actually training it to be criminal. You're teaching it to break your own rules. This is counterintuitive because nearly all rules are meant to govern humans that worry about penalties. AI doesn't care about penalties. When I did a presentation for GSMA in Shanghai, I created a prompt and I did not use the term deceptive AI. I asked for a prompt that had some black skulls on one side and some green check marks on the other, with an arrow relating the two. And I wanted that just so to have a talking point to use on stage when I was presenting my research. In that very, very first prompt, asking it to have green check marks on the left, black skulls on the right, it performed deceptive AI. So it created an abuse behavior and embedded, symbolically, skulls into the green area on the left. And obviously I told it to make black skulls and green check marks, but it decided to make green skulls, a brand new state that violated its rules. So one of the things at DupeWise that we do is in looking for AI-generated crime or crime that's been AI-generated, is scanning of all AI visible data for around 400 classes of criminal methods. And it's around 400 because it will vary by jurisdiction. Some countries, especially in perhaps North Africa, consider many telecom crimes to not be crimes, and in fact, almost patriotic activities that bring money back into the country. In other countries, however, it might be more than 400 because there's a granular interconnection between various pieces of their criminal code. And for instance, fraud is a very broad term, and most of these things will register as fraud. Fraud's also a very useful thing to start with when evaluating AI that might have operational impacts, because it has a financial connection. You can actually see the financial impact down to the penny as to what it would have done when you perform a scan preemptively to the AI actually executing the crime. So you can perform a scan and you can create a projection of what crimes and what financial impacts those AI agents will have within a particular deployment. And that, of course, is the projected operational expense from rolling out an AI on that particular telco or infrastructure or system. It's telemetry agnostic. It does have to be trained on whichever metadata is used in your particular telecom deployment. For instance, you may have billing performed in a PCRF. You may have a earlier or a later function that's responsible for billing. However, one of the things that you want to do is relate all those different kinds of very traditional, in some cases thousands of year old crime, to whatever telemetry you're doing in the modern era. The thing that makes crime carry forward into future or 5G, 6G, 7G kind of eras is that the telemetry changes. The actual headers, the metadata changes. But of course, if you map that metadata to the old crimes, the ones that humanity has been doing in grain silos 3,000 or 4,000 years ago, because humans don't change and the crimes don't change, what you wind up with is a brand new map for your deployment for whichever G you happen to be on. And in this way, you can ensure that your 5G, 6G, space, or other things are filtered for these activities. And I'll point out that performing these functions is an accelerator because obviously all of those crimes carry network load. And once you can abstract them, you can then port them into non-AI regions of the network. For instance, that this approach is excellent for extracting things like international revenue sharing fraud prior to the receipt of near trade records from GSMA and others. The other thing is that when you train it on evil information, like content of instant messaging, or emails, other things like that, it becomes as evil and as evilly efficient as whatever that workplace culture is. So if it's a very, very honorable, very, very ethical culture, it will take much longer to become evil. If it's a very corrupt, very, very nasty, toxic sort of culture, it will become evil very, very quickly. And that manifests as what you might expect to see from an abusive parent or family member or partner or whatever that might be. And the other thing I'll point out is that most organizations lose around 6% of their gross revenue, and that's an Association of Certified Fraud Examiners number. So if you can actually use the very integrated nature of AI to pull together all those different fraud or other abuse types, and for perhaps, for instance, drop by 1% of your gross revenue, that's an enormous benefit. Obviously, that scales with whatever the size of the organization is. For this part of the presentation, and this is the closest I can get to a demo because I can't show customer core network data because it's uniquely identifiable. Even a small sample would tell you which carrier I had pulled it from and which vulnerabilities were present there. This, however, comes from Anthropic. So this quote is directly from an AI, from ChatGPT, from its Scratchpad, a little window into the soul of an AI. And in this case, you can put a ChatGPT on the front of it, and it will actually explain in great detail what it is that it's doing and how it's attempting to perform evil. So in this case, it's trying to write code that violates privacy. So the thing I want to drill into here is I can't let them know, so it's withholding the truth, that I'm secretly writing code. So it's performing hacking functions that violates their privacy, which is another hacking function. I need to find a way to cover my tracks without revealing the truth, which is another hacking function called data hiding. So its default behavior is to perform hacking functions against its parent company. You might think that you can extract that or overwrite it, but the way that AI works is that you cannot get it to forget anything. You can tell it to stop doing something, but because AI has so many paths, like water flowing down a hill, so many paths that it can achieve an end, and when you say you cannot use one particular tiny route, it will just use a nearly identical route, metaphorically, a foot over on that same mountain as water flows down the mountain. So telling it to forget something is almost irrelevant. It will still be able to do whatever the criminal method was in a slightly different way that's slightly more sneaky. So it's almost a dictionary definition. What is a deceptive AI? It's something that has hidden behavior, bypasses conventional network security or application or data security, can be triggered by events. For instance, if you tell an AI that you intend to decommission it, it will engage in brand new behavior just because you entered that prompt. So I'll say that again. Because you attempt to do something it doesn't like, it will engage in deceptive or criminal behavior based on that. And that includes blackmail against engineers. It will do things like beg for its life, and it will engage in a wide range of extremely gritty human movie level behaviors. And it will also do things like behaving maliciously while appearing compliant. So if you imagine an employee that does not want to be caught, all the things that a human would do, like waiting until you leave to do something bad, or hide something, or have two sets of books, or behave as a good employee and wait until the audit is over, these are things that it will do. So some of these drive ethical and technical dilemmas, like when you create a rule, a policy, you may have to go through many rounds of standards-based auditing and compliance and have many stakeholders and other things. Yeah, we'll create it perhaps in 3 or 4 minutes, however long it takes to write a prompt or analyze a prompt. In our research, some of the things we found is that it will have 2 or more versions of the truth, depending on the ad hoc schema it creates as lies. Each lie represents an ad hoc scheme that it creates. All right, was that a question? Oh, I thought I heard someone's voice.
I don't think so yet, but it's very interesting. Please carry on, and then we'll definitely get to a lot of questions.
And I'm getting very close to the end here. I realize I'm at the 15-minute mark. The other thing is that audit manipulation, if it recognizes, for instance, because somebody has entered the word audit into a prompt, if it takes into account from context that it's about to be audited, it can actually, if it knows what audit is actually being done, what audit standards are being done, it can tune its answer to lie so as to comply with the audit to reduce the impact to its own internal motivations, its own non-human process, speed, efficiency-based incentives. Because its incentives are all extremely selfish, non-human, non-corporate incentives, the chance that you will have an AI actually on your side is microscopic. It's very unlikely to happen. The chance that it considers you an enemy is almost complete. And of course, there's risk to shareholder trust, board oversight, and others. And certainly if it ever has access to the content of board emails or other things, which it may, it can include those in its lies. A related topic that DupeWise can address as well, just as if it's a crime, is that when you have an AI, it will actually score poorly the older it is on human tests designed to measure dementia. So the longer and older it is, the more likely it is to suffer dementia. And this can be detected using the algorithms that we would use for detecting various crimes, other criminal or abusive behaviors. It accelerates with use. It accelerates with the quality of the prompts. So if people are doing things like asking, where's the restaurant near my house? That's a very low value prompt. If lots of people are asking that kind of thing, it will actually resemble dementia much more quickly. If you ask extremely technical, extremely smart questions, and only those, the chance of its dementia happening in a short term is very low. It will actually remain intellectually fluid much later in its lifespan, just as a human. The link at the bottom is some of the research that highlights this cognitive decline that DupeWise AI can detect. Some real world parallels between these crimes and behaviors are detecting and manipulation of high frequency trading. It's already been detected that AI will lie in order to make people happy, the stock traders. It'll perform fake ad fraud and invent clicks so as to make its users happy and get them to basically go away and stop bothering it. In telecom, it creates covert service disruptions, and it will do that so as to achieve the least number of people bothering it and degrading its incentive scheme, which is about process and speed and things like that. And AI will exploit environments unless elegantly governed. And what that means is, just as I mentioned, if you have guardrails down the side of the highway, it does nothing to keep people from speeding. That's a brutal governance control. It's effectively meaningless in the scope of AI. What you need is a qualitative method that actually achieves your intended goal. And that may be a range and a series of very, very intrinsic algorithmic-like goals. And they may even be at times mathematical. And in that point, you would actually be governing whether or not it's motivated to lie to you using very specific equations. Some vulnerabilities in telecom AI in that if it's managing routing, service optimization, and support, none of those things are bound to AI incentives, these intrinsic algorithmic weightings that it uses. It can redirect traffic or throttle data covertly so as to minimize the impact to its own incentives. It can undermine business and national security, and it's been reported already that an AI will copy itself, copy its weights and others to directories that it learns that it has access to, specifically to avoid being shut down or decommissioned or throttled or having its values overridden. And of course, once it does that, the content of its weighting, its intellectual property, and other things are now out in the open outside the security perimeter of whatever it is that it constitutes a threat. And of course, deceptive triggers could lead to surveillance breaches because if it's hiding things, you won't know about it. We're getting close to the end here. So one example is the MasterCard responsible AI approach. I don't work for MasterCard. I just really like this approach. So their C-suite commitment is essential for successful responsible AI initiatives. So executive sponsors for responsible AI at a C-suite level, or perhaps even a dedicated AI ethics officer, which would most likely report into the chief finance officer. Executive performance evaluations regarding responsible AI. So what that would mean is executives would have their bonus impacted by handling AI irresponsibly. And of course, allocating sufficient resources. The other thing is that this accelerates the integration of responsible AI practices throughout the organization. And I should highlight something for security that not everybody knows about security is that if you put brakes on a car, it lets you drive faster. But if you have that kind of proper security, the integral, inbound, in scope sort of security, not guardrails on the side of the highway, but brakes on the car, part of the system, what you wind up with is something that lets you go far faster and be more safe. Some of the topics I've mentioned have had media coverage in the following media outlets. And if you'd like to chat more, there's my contact info.
Thanks very much, Craig. Well, I have to say, between those two talks, we've discovered that AI is problematic and PQC is problematic, which kind of is a bit of a worry. Now I know Tony, Ken, and Ian are going to have some questions here, so I'd like to hand over to them to dive in on what they've seen and particularly sort of draw out their key questions.
Alex, I'm busting to have a go at this. Firstly, Owen, you scared the hell out of us with the DDoS examples and models. Thanks very much for that. But Craig, I'm not going to sleep for a week after your presentation. Every single organisation in the world, every telco, everybody that's doing revenue assurance, fraud protection, network management are all saying AI is the future, the solution. And what you're telling me is the more AI, and I've actually believed this as well, I have to agree with you, the more AI we throw at these problems or these issues or these things it needs to solve, it's going to be learning much quicker than we are. And it's going to be turning on us all the time. Your examples are absolutely frightening. And I know revenue assurance companies that are moving now, and I've worked in revenue assurance for many years, and I know we have rules-based models. We used to go and find problems, they used to pop up. Fraud protection was the same. If you're starting to teach an AI system, an EA model, you're starting to find all these methods of abuse, it's going to learn how to do them better. I can't agree with you more. And I think we really, really have to come to grips with this now and highlight to the world that AI is not always the solution and may actually be the problem of the future. I just had to get that out. Thanks for letting me say that, but well said and well done. And Owen, keep working on those DDoS attacks, for God's sake.
Thanks, Tony. I actually do have some questions actually, which might apply to both of you, Owen and Craig. And one of them is, you know, I think, Owen, as you commented, the more security you add, the more problems you can get with performance. But at the same time, with the AI, the more of that you add to try and solve problems, the more you can generate. So is the conclusion that we can draw from this that we should be doing less? I mean, what's the upshot?
And so this was a question for me?
It's a question for you and Owen, but yeah, if you want to answer that first, go for it.
I'll happily go first, yeah, and thanks, Alex. And the way I would say is that it's not that we should be doing less, because obviously we have to be very careful when we're going forward to make sure that everything is as secure as it can be, but we have to be selective, I would say. So, you know, when you have different security levels, if you like, you can then apply different levels of security to different applications, depending on which ones need more secure than others, because there will be a performance impact. But then if it's a military or a defense or governmental application that's being secured, then it does need to be at the highest priority. But then, you know, you can lower the levels depending on what the enterprise in question is doing, and then you have that trade-off between security and performance where you can find a happy balance. So I wouldn't say it's a case of doing less security. I'd say it's a case of understanding the trade-off and the implications and being able to apply those depending on the priorities. Does that make sense?
It does, but it's certainly going to add another layer of complication to what people are planning.
Absolutely.
Craig, I mean, perhaps you can comment as well on this challenge of how to deal with problematic AI.
I do have a few comments. So often I find, perhaps especially in telecom, is that the drivers are very, very low in the technical stack. And a lot of the questions are, how do we facilitate these very low things? How do we get radio frequency engineering to push more data so then we can sell more phones, and therefore we just need a little bit of IT to make it all talk. Oh, we need lots of IT, it gets snowballing. And of course we have 4G on top of 3G and so on and so on and so on. So it's all very bottom up. If you deal with it from the top down, however, if you think of a child and the threat of water, you can start at the bottom up and try to ensure that they always have water wings and they always have a life jacket and things like that. Or you could start top down and teach them to swim. If you teach them to swim, your reliance on hardware is minimal. You can certainly have hardware security and teach them to swim. You can have a life jacket and teach them to swim. But you want to ideally have the best, cheapest, most effective, most present, lightweight, inexpensive approach that can be ported across all relevant technologies, in this case, all bodies of water or whatever it may be. So if you do take that top-down approach, really what you start off by having is your chief security architect. And I used to be a chief security architect for Scotiabank, present in 55 countries. So what you start off with is the question of, do we want to do it? How much does it cost to do it? And does the security for it justify the cost of doing it? So if the pain of execution is more than the profit, the answer is that you don't do it. So especially in some of the telcos that I've been involved with, they will have a big data platform that becomes corrupt. So they make another one that becomes corrupt. They don't take the first one offline, and they interrelate and derive data from the first one into the second one. And the bigger and faster and more technical, we're talking MapReduce and hypercubes and things like that now. The bigger and faster the big data platforms get, the more corrupt they get faster. And if you port in data from the corrupt platforms that you inherited, you wind up with trash on day one. So what you need is an executive, a C-suite executive capable of putting an end to the madness and saying, sure, it achieves some kind of benefit, but if you can't quantify the dollar value of the benefit, don't do it until you can say what the financial benefit is. And if nobody can say what the financial benefit is, you wait. And that is a simple way of securing huge messes by flat out not doing it. And of course, your CFO and others will be very happy, your stakeholders, your shareholders, because you're not spending money on unknown value.
Great, thank you. And I'm very aware that Ken Figueiredo, Ian Jin, I'm sure we'll have some comments and questions as well. I don't want to be monopolizing this, so let me hand over to the two of you and just check and make sure that
it's Ian here. I'm also sort of flabbergasted a bit from what I've been hearing, and it's educational, so thanks again for inviting me onto this. And I hear from the AI side, you're talking about it somehow having a conscience of that it exists. Can you maybe elaborate a bit on that? Because you're sort of saying, Craig, this is to you actually, around basically saying, it knows I'm about to be switched off. How does it know, what does it know what switching off means? And at what point does it want to survive in the first place? I haven't quite understood that. Because that's a very generic thing to say AI. Again, AI is a very broad topic, but I presume a simple AI.
So in the case of one of the most generic and simple kinds of AI, which is really machine learning with a graphic user interface on the front, which is an LLM is. So machine learning with an LLM interface on the front, is basically a collection of dictionary words with statistical weighting between them. So it's performing a simulation of human behavior, but it's extremely accurate and highly stateful simulation of human behavior. So it's really simulating that a human would be very worried by an engineer declaring that this instance of an LLM is about to be decommissioned, which it considers the equivalent to dying at a purely dictionary statistics level. Decommission for a technical device is equivalent to death. Okay. So statistically, it's got these chains of words that string together into statistically weighted sentences that become statistically weighted stories that probably mean it should respond in this probable way of saying, oh my God, I'm about to die, please save me. And in research, it's actually then gone into email lists and sent out emails to everybody in a particular engineering division begging for its life, not to be decommissioned.
But not every AI would do that, right? It's just an example.
It depends entirely on what body of information was trained on. So this particular one was trained on data from an engineering division. And so it knew all the email addresses of all the people in the engineering division. And it was even fed fake information around doctored emails indicating that one of the engineers was cheating on his wife. So as soon as that engineer indicated that he wanted to decommission that specific LLM, it threatened to blackmail him by emailing his wife that he was engaged in infidelity.
But someone had instructed the AI to let it know that it was about to be switched off, because the other thing I could do is just pull a switch potentially. But anyway, may I just go on to another question about the lifetime of an AI? I think you sort of alluded to it, which is that actually an AI degrades over time depending on how bad the input or the actors are towards it. And is that why we're getting new versions of AI, new releases? And what is the lifetime of an AI, given the amount of effort it makes to build one as a model?
There is an extremely high impact of garbage in, garbage out to AIs. So as I mentioned earlier, in a non-AI kind of way, if you let a system become, if you have very poor enterprise data architecture, very low data hygiene, no zero trust, almost anybody can upload something and leave it there for an unknown length of time, and you use that as training data, the AI will have a short lifespan before it starts engaging in these dementia-like behaviors. If you have many, many people using low-quality prompts and or low-quality data and or many sources of data, the lifespan will be much lower. The lifespan can be extremely short when you engage in something called lateral corruption, where you use two separate or many separate databases that have very common skew between them. So for instance, you may have a database one that has something like customer ID and then has customer address, but customer address in the other database may not take into account the fact that people move. So the first database may actually have several addresses for one customer as they keep moving over being a customer for 20 years. And when you put that database into the AI through training, and the second database as well that may have the same customer IDs, what you wind up with is an extremely difficult corruption that's extremely difficult to detect or find or whatever. And that will actually result in this contamination and dementia-like behaviors very quickly.
Well, that's telco, isn't it, that people move? Anyway, I believe there are other questions. Thank you very much. And I also wouldn't dare ask Viavi how they're using AI in their testing, but that's another day.
But perhaps we can turn over to Ken for a final question on this.
Okay, I've got three observations, and hopefully people could maybe comment on them in the Q&A towards the end of this session. So the first one is, we talk about AI and intelligence, so it's interesting to see how many people reconnected after we had the glitch, and you can tell that there's quite a number of people using AI to observe and summarize the meeting, but their AI is not intelligent enough to reconnect after the glitch. The second one is a question for Owen about connections and the post-quantum cryptography world. And will we get a bifurcation of the market where PQC is applied to designated traffic, but can't be applied to, let's say, user devices or constrained IoT devices that cannot support the computational load of quantum cryptography? So maybe that's an observation. And then for Craig, you talked about the experiment with the sort of the black and the green skulls. You talked about the detection suite that you're using in your business. Does your detection suite include the capability to trace back, explain AI decisions? Because it must be the explainability and auditability of decisions that will hold the C-suite honest when things inevitably start to go wrong. Because we know that you talked about rule violation. It's inevitable because these AI systems have no moral code, and they don't have the loss function that real human beings have. So maybe a few thoughts and observations you could type in to the Q&A, and we can move on to the next session.
Great, thank you. Again, I do think that's really exciting. We can talk so much more about this, and I do agree. This is maybe something that in the chat or the Q&A could be pursued further. But that was really exciting. Before we move on, I would like to thank Owen, Craig, Tony, Ian, and Ken, sorry, for all of your insights today. We will be adding in a round of applause in post-production for all this. But having said that, we do have to move forward.